11.3 Expected value. Expected value, also called expectation, is often used to determine the expected results of an experiment or business venture over the long term. So the formula for that is P1 times A1 plus P2 times A2 plus P3 plus A3 plus dot 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 Pn times An. Basically, it's however many scenarios you have, that's how many sets you're going to have. So if you have 4 scenarios, you'll have A1, P1 A1, P2 A2, P3 A3, P4 A4. So it's however many sets you have. The symbol P1 represents the probability that the first event will occur, and A1 represents the net amount won or lost if the first event occurred. P2 is the same thing, it's just the second set, and so on. So example 1. JetBlue Airlines is considering adding a route from Boston to Minneapolis. Before making a decision, the company needs to consider many factors, including potential profit or loss. After considerable research, JetBlue estimates that if it adds the route, there's a 60% chance of making an annual $800,000 profit, a 10% chance of breaking even, and 30% chance of losing $1 million. How much can JetBlue expect to make annually on this new route? So you see how we have 3 scenarios? We have the making money, break even, and losing money. So we're going to have 3 sets. So we'll have P1A1, P2A2, P3A3 because we have 3 sets. So let's bring out those 3 sets. If they add the route, there's a 60% chance of making $80,000. So there's 60% chance of making 800,000. I said 80,000, my bad. It's 800,000. Then there's a 10% chance of breaking even. So breaking even, that means no money. That's $0. Meaning you didn't lose anything, but you didn't gain anything. That's $0. And then our third scenario is a 30% chance of losing $1 million. Ooh, that's a lot of money, right? If we're losing $1 million, if you're losing, isn't that negative $1 million? So be careful with the wording. So now we just need to plug it into our formula. So since we have 3 scenarios, we're going to be using the formula that looks like this. P1 times A1 plus P2 times A2 plus P3 times A3. So our P1 A1, they're going to come from our first scenario. Our P2 A2 are going to come from our second scenario. And our P3 A3 are going to come from the third scenario. When we plug stuff into formulas, we don't use percentages, we use decimals. So let's just go ahead and change our percentages into decimals. So your P1, your P's are your probability. Your P is the probability, which is always the percentage. So our P1, it's 60%, but we don't use percentages, so it's 0.6. And then our A1 is what you earn, which is $8,000 or $800,000. Our P2 is 10%, so that's 0.1. You can put the zeros if you want. It means the same thing. It means the same exact thing. And then our A2 is $0. Then our third scenario, so P3, it was 30%, so 0.3, or you can put 0.30. And then our P3, or sorry, our A3 is negative $1 million. So let's go ahead and put it into our formula. We have expected value equals P1 times A1, so P1 is 0.6, A1 is 800,000. Then we're going to add that to P2A2, so P2 is 0.1, A2 is 0. And then we add that to P3A3, so P3 is 0.3, A3 is negative 1 million. And then from there, we just use our handy dandy calculator to simplify. So 0.1 times 0, this goes away, because anything times 0, it goes away. So 0.6 times 800,000 is 480,000. And then 0.3 times 1 million, and remember it's negative 1 million, so it's going to be negative 300,000. We combine like terms to get $180,000. So with this data, they can expect to earn about $180,000 if they added the route from Boston to Minneapolis. So is it smart? I say so. You're earning money. If you're earning money, you're, winning in business. So yeah, they should add this route because it is making them quite a bit of money. Example 2, test taking survey. So Maria is taking a multiple choice test in which there are 5 possible answers for each question. The instructions indicate that she will be awarded 2 points for each correct response, lose half point for each incorrect response, and no points deducted or added for any answers left blank. So this is very much, and if you're taking the SATs, this is how they're set up. If Maria does not know the correct answer to a question, is it to her advantage or it's supposed to say or disadvantage to guess the answer? If she can eliminate one of the possibilities, is it to her advantage or disadvantage to guess the answer? So let's do part A. So part A is just asking if she guesses, is it going to be disadvantage or an advantage? That's what A is asking. So A, we need to know what the probability of getting something right. So total, there are 5 questions, or 5 choices. Sorry, 5 choices. And I got that because it's 5 possible answers. So for A, we need to know the probability of getting a correct answer and the probability of not correct answer, so incorrect. So only 1 out of 5 is a correct answer. That means 4 out of 5 are incorrect answers. Then it told us that if it's correct, it's awarded 2 points. So if she gets it, that probability of 1/5, she gets 2 points. If she guesses and she's wrong, she loses half a point. So she's going to lose half a point. Lose means negative. So we only have 2 scenarios. Since we only have 2 scenarios, we're going to be using P1A1 plus P2A2. And our P1A1, they come from correct, and our P2A2 come from incorrect. And since they're not percentages, we can work with them as is. So we have expected value equals P1, which is 1/5, times A1, which is 2, plus P2, which is 4/5, times A2, which is negative 1/2. And since we're multiplying, let's go ahead and put a 1 underneath this 2, and we're going to multiply straight across. So we have 1 times 2, which is 2, 5 times 1, which is 5, and then 4 times negative 1, that's negative 4, 5 times 2, that's 10. We can go ahead and subtract these. If to subtract them, we need the same denominator. So 5 and 10, let's make them both 10, so times 2 times 2. So we have 4 over 10 minus 4 over 10, and we get 0. Now, what does an expectation of 0 actually mean? So what we found is the expectation is 0. Therefore, over the long run, it will neither gain or lose points for guessing. So she's not going to gain or earn points for guessing. It's kind of just cancels each other out. So is it an advantage or disadvantage? Neither. It's nothing. If she can eliminate one of the possibilities, is it to her advantage or disadvantage to guess the answer? So this is where I want you to take the moment to pause and try B on your own. Let's do it together now. So remember, there's a total 5 choices. There's 5 choices. But she can eliminate one. If she can eliminate one, we have now a total of 4 choices. Because one is gone. So the probability of correct, because she eliminated one that was for sure wrong. So the probability of correct now is 1 out of 4, and she gains 2 points for that. Incorrect, that's now 3 out of 4 because she got rid of one of them that was wrong. And if it's incorrect, it's negative 1/2 points. So we only have 2 scenarios. Let's go ahead and put them back into the same exact formula. So we have expectation equals P1A1, so 1/4, and 2 plus P2A2, so P2 is 3/4, A2 is negative 1/2. We multiply straight across, so 1 times 2 is 2, 4 times 1 is 4, and then still multiply straight across, so 3 times negative 1 is negative 3, 4 times 2 is 8. We need the same denominator, so we're going to make them both 8, so times 2 times 2. We get 4 over 8 minus 3 over 8, 4 over 8 minus 3 over 8, and we get 1 over 8. It's to her advantage because it's a positive outcome. So Maria on average will gain 1/8 of a point when she guesses with eliminating one choice. So if she can eliminate one choice, oh, definitely guess, because you're going to gain over the time 1/8 of a point every time you guess. So if you guess on 8 questions, you can most likely gain a point. Example 3. When Josh attends a charity event, he is given a free ticket for $50 for a $50 door prize. A total of 100 tickets will be given out. Determine his expectation of winning the door prize. So we need to know the probability of Josh winning and Josh losing, because it doesn't give it to us. So if there's a total of 100 tickets, and he only has 1 ticket, it's 1 out of 100. And if he wins, he gets $50. Now, if the probability of losing, that's 99 out of 100. And if he loses, nothing happens. It was a free ticket. It was free, so like nothing happens. If nothing happens, we're actually talking about 0 because it was free, right? It's like one of those things like you get a free lot or a free raffle ticket when you go places. It doesn't hurt you. You're just there, so you might as well try. And you win. Awesome. So we have 2 scenarios, our A1, P1, A2, A2. So our winning is the first scenario. So we have expectation equals 1 over 100. That's our chance of winning, and if we do win, we get $50. And then our chance of losing is 99 out of 100, and if we lose, nothing happens. So 99 over 100 times 0, that goes away. So we're left with 50 over 100, which is 1/2. 1/2 in money is 50 cents. So in the long run, he can expect 50 cents. Alright, expectation and fair price. At a game of chance, the expected value is found to be negative 150, and the cost to play is $4. Determine the fair price to play the game. So, fair price is expected value plus cost to play. That's how they find fair price to play. So our fair price is expected value. So the expected value is negative $1.50. The cost to play was $4. So the fair price to play this game is $2.50. So the fair price to play the game is $2.50. If it costs $2.50, the expected value would be 0. Over time, you wouldn't gain or lose money. So fair price is what's going to make me or the person playing this game break even. That's what we're talking about fair price. Of course, it's never fair, right? It always costs more, so the house gets money.